In this session, we are going to show how to measure the relative density of a solid using a balanced lever. This is our procedure. Of course, before we get into the procedure, we are going to use this balanced lever right here. This is a lever that's a fulcrum. This is a weight W, whose weight we know. We call this a known weight. And this is W1, whose weight we do not know. So what we do is that first of all, we are going to balance this lever. We are going to balance this known weight with this unknown weight. And after this lever is balanced with these two weights there, we then go ahead and balance it off. We measure D1, the distance between the known weight and the fulcrum, and also the distance D, the distance between the fulcrum or the pivot and the unknown weight. Now the distance D is going to be maintained constantly throughout the entire experiment. But this D1 will be changed depending on whatever new measurements we'll be doing. So of course here it's going to be W. We're taking moments. W times that distance from the fulcrum, which is D1, is given by W1 times the distance D1 times the distance D. And from here we go ahead and find the weight that we do not know, W1, by making it the subject of the formula. And this is our first expression. Our first expression here, we're trying, this W1 is equivalent to, or it's representing the weight of this sinker in air. Drop this sinker in water, and when we get this sinker in water, we keep this distance D constant, and then we only adjust the distance D2, the distance between the fulcrum and the known weight. Then afterwards we take moments. W times D2 is going to be equal to W2 times the constant weight distance D. And then we go ahead and find W2, the weight of this sinker when it is dipped in water. Now from our theory, we know that when you try to find the relative density of a solid, it is given by the weight in air, divide that by the apparent loss in weight of that solid. Now of course the weight in air is given by WA. That's the acronym we are giving it. Divide that by the apparent loss in weight. The apparent loss in weight of the solid is the weight in air minus the weight when that solid is in water. Now, according to our experiment, the weight in air in this case is given by W1. W1 is our weight in air. So in this case here, this is going to become W1. Divide that by the weight in air still, which is W1 minus the weight when it is dipped in water. When the sinker was dipped in water, we labeled that W2. So we go ahead and make the necessary substitutions. This W1 is this. W1 is the same as W times D1. Divide that by D. Divide that by, we are going to divide that by the apparent loss in weight of the solid. And of course, the apparent loss in weight is equivalent to the upthrust that body experiences when it is dipped in the water. So that is going to be divide that by W2. Of course, this is divided by W1, which is still W D1 over D. Subtract that minus W2, which is this, W D2 over D. To continue, this becomes W D1, divide that by D, divide that by, this is W D1 minus W D2, divide that by D. This becomes W D1 over D, multiply that by D, the reciprocal of this, which is W outside the brackets, into D1 minus D2. This D goes with that D, this W cancels with that W. You remain with an expression such as D1, divide that by D1 minus D2. And with that kind of expression, after using that experiment, you are able to measure the relative density of a solid using a balanced lever. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.